Hi everyone, today we are learning about the rules of surds. Surds are radicals which are irrational square root numbers and they cannot be simplified. Irrational numbers are numbers that cannot be simplified from decimals to fractions or any whole number. Another aspect of a surd is that they are real if they are equal to 0 or bigger. And they are not negative, of course. There are many examples of irrational and rational radicals. Here are three examples here: square root 2, square root 3, and square root 7. These three numbers are irrational radicals. Now we'll be going through these three radicals here using a calculator to demonstrate what a radical should look like as an answer. Sorry if the screen is not that great, but it's good enough to see. I hope to get a new one soon. Let's start with square root 2. Your answer should look like this, but when you press this button there to get a fraction, you're not going to get anything, so that means it is an irrational number. Now we're going to square root 3. Let's do that. There's the answer there. Now pressing this button, you should get the fraction. Well, I'm not getting anything there. That means it's an irrational number. Now we'll be going to square root 7. Let's do the answer here. Now we should press that button to get the fraction or any whole number, but it's not coming out as well. That also means it's an irrational number as well. So these are three examples of irrational radicals. Now we're going to the three examples of rational radicals here, starting with square root 4, then square root 9, and square root 16. So these are three examples of rational radicals. So we have two examples of irrational numbers. We have square root 2. Now when you put that in a calculator and you square root it, you're going to get this answer here: 1.414213,562. And when you try to make that a fraction, the answer is the same. Now when the answer is the same, that means it's an irrational number. So that's what makes it a surd. Let's use a calculator anyway to demonstrate this. So I'm going to put square root 2 there. The answer should be exactly the same. Yep, just like the one on the paper. Now trying to make that a fraction, let's see what happens. Am I right or wrong about this? Let's press it. When you press that, you should get a change. When it doesn't change, that means it's an irrational number. Irrational numbers do not change after trying to make that into a fraction with a calculator. Now we're going to do square root 3. The answer should be the same here. Right, see that? Now we're trying to make that a fraction here. So if you try doing this by pressing the fraction button, the answer is going to be exactly the same. So therefore it's also a surd, just like the one above. So now let's go to the other two examples, rational radicals. We have square root 4 and square root 16. Now if you square root 4 and using a calculator, you'll be getting this answer. You'll be getting 2, and that is a whole number. That's not even a decimal number that needs to be simplified to a fraction or converted to a fraction. The same will go for square root 16. You do the same thing with the calculator. The answer is going to be 4. That does not leave behind any decimal number. It's a whole number as well, just like the one next to it. Now moving on to the properties. So first of all, if the square root with a number is bigger than a 0 and it's not negative, then it's also a real number. It's only a real number if it's bigger than or equal to 0. The same will go to the second rule here. When you find a square root with two numbers here, and you can separate them like this, they are also the properties of surds. Is also one of the properties of surds. If both a and b, the square root of a and the square root of b, are bigger than or equal to 0. And that's and, not either. It is both. You cannot have them like with a minus or anything below 0. Now the third part here is if the square root has a division of a number a over the number b. Now you can divide them into their own square roots here. They can have their own square roots, and that's also if square root a is bigger than or equal to 0, and if square root b is bigger than 0. It cannot even be 0. Otherwise, when you do that, you'll have a math error on your calculator. It's just going to show that, which I'm going to explain later on in a few moments there. Now we're going to start with the first rule, demonstrating with square root a. Let's just say if square root a equals to square root 2, right here. Now the thing about the square root here, the square root number 2, is that it's not negative, and therefore it's a real number because it is bigger than 0. It's not even equal to 0, it's bigger than 0. So it fulfills the first rule of what it is to be a surd. Okay, for instance, I'm going to demonstrate this with another number, square root negative 1. If square root a was square root negative 1, would that even fulfill the first rule here? Would that even be considered a surd if this is broken, if this rule is broken? No, the answer is no, because it is a negative, and therefore it's not even the number to consider here. It's not even the real number, because if you want to have if it's going to be a real number, then it has to be bigger than or equal to 0. That is also one of the rules which I mentioned before. Well, there's clearly one way to tell if this is the case. How do we do that? We can simply use a calculator, which I'm going to do right now. Now, let's start with square root negative 1. Now, if we put this in a calculator, you can see here, the kind of result you should be expecting is math error, which also proves that even the calculator will tell you that it's not even a square root number that can be recognized. It'll even tell you that it's not worth recognizing this. But the crazy thing is, can you even imagine a calculator telling you that this is a math error? Now, if we do the same thing here for square root 2, it would even be obvious to you that the answer is going to be different. You should expect the answer to be different. So I'm going to use the calculator right now. It should come as a irrational number with decimals, with a decimal, with a long decimal, which cannot be simplified into a fraction. You can see it right here, which I'm going to write right now. So now let's move on to the second rule of the surd, which consists of two numbers in a square root. Now that is equal to if each of the numbers had a square root each. It can be simplified back to square root AB from this. But that's in a condition if these two numbers are bigger than or equal to 0. So let's put an example here. Let's say square root 5 times square root 3. Now if you try to calculate them manually, 5 times 3 in one square root, you get square root 15, which is how you usually solve the surds here. Now, if you try to solve this square root by using a calculator, the answer is going to look like 3.872983346. Now let's try to use another example. So let's put another example, square root -5 times square root 3. Now if you put this in a calculator, or if you try to do this manually, let's try that first. If you do it manually, you're going to get -15 square rooted. But if you try to do this with the calculator will tell you differently. Now let's do it here. The result is going to be math error, which does show that this does not fulfill the second rule of the properties of surds. Now going to the third rule here of square root a over b, which is equivalent to having square root a over square root b. Now this condition can be fulfilled if the a is bigger than or equal to 0 and if b is bigger than 0. Now let's try to put an example to make this a bit easy for us to understand here. We are going to put 18 in that square root and 6 in that square root. If we simplify it, it'll be equal to square root 18 over 6. The answer is going to be square root 3. After simplifying the division, you'll get this answer, and if you do this manually, that's what you get. Now, if you do this with a calculator, your answer should be 1.73205868. Now, moving on with another example here. If you try to do this with 2 over 0, the answer is going to be 0, right? But that's what you think if you could do it this manually. However, the calculator will tell you different. When you try to put this inside your calculator, your answer is going to show math error. But when you try to solve this with a calculator, you are going to find math error instead, because it does not fulfill the rules to have a surd here. The denominator 0 is not bigger than 0. It is 0. But if you flip these numbers around and expect something different, you would expect something different here. If you solve it manually, you'll get square root 0. But if you put it in the square root, you'll not get math error. You'll only get 0. Full stop. It'll be exactly the same answer. Thank you for watching.